Right, we have here a uniform rod AB attached to a wall by a smooth pivot at A and held in position by a string going from C to B. The length of the rod is 8A and this distance here is 6A. Now, by taking moments about A, find the tension in the string. Now then, this question is about forces, so I'll draw all the forces acting on the rod on the diagram. First, the rod is a weight, W, and that force acts in the middle of the rod because it's a uniform rod. Secondly, there's a tension in the string acting along the string. And thirdly, there's a force on the rod from the wall. Now that can be split into a horizontal part and a vertical part. I'll call this RH, reaction horizontal, and RV, reaction vertical. Now then, we're taking moments about A, part A. Now, when I take moments about a certain point, what I will do is I will sum up each of the forces multiplied by the perpendicular distance of that force from the pivot. Since RV and RH act through the pivot at A, they will contribute no moment. So the only forces that I'm interested in are the W force and the T force. Now it's going to be easiest for me to actually split my T force up into two separate components, a vertical component and a horizontal component. So I'm effectively replacing my blue tension force here with two separate red ones. Now then, if this angle here is theta, then this component of the T force is T cos theta, and this component is T sine theta. Now I can predict that it's going to be useful to know what cos theta and sine theta are, so just up here I'm going to work that out. I'm going to redraw my blue triangle and label the sides 6A and 8A. Now by Pythagoras, I know that this side of the right angle triangle will be 10A. That's the square root of 6A squared plus 8A squared. Now then, this angle is theta. So from this triangle I can tell that cos theta is going to be 8A over 10A, or 4/5, and sine theta is going to be 6A over 10A, which equals 3/5. Now then, taking moments about part A. All my forces are fairly clear, so I'm not going to miss any out. RV, distance 0, no moment. RH, distance 0, no moment. Force W, distance 4A, so moment. Force times distance, and it's positive because it's a clockwise moment. Now then, force T cos theta, 0 distance from the pivot, the line of action of that force goes through the pivot, therefore 0 distance, therefore no moment. Force T sine theta has a distance 8A from the pivot, force times distance there, and this time the moment is negative because it is anti-clockwise. The T sine theta force is trying to take us anti-clockwise around the pivot. Now then, those moments sum to 0 because the situation is in equilibrium. Now then, this equation is fairly easily solved for t once we substitute 3/5 in for sine theta. So, rearranging and simplifying slightly, 4aw minus t times 3/5 times 8a equals 0. Dividing through by a, dividing through by 4 gives us t equals 5w over 6. Now then, the next part of this question, calculate the magnitude of the horizontal component of the force exerted by the pivot on the rod. Now then, part B, we're to find RH. Now we will do that by balancing the horizontal components of all these forces. So, resolving horizontally. From the diagram, RH minus t cos theta equals 0. But we know that t is 5w over 6, and we know that cos theta is 4/5, so I'll substitute that in. RH minus 5w over 6 times by 4/5 equals 0. 5's cancel. RH equals 4w over 6, or 2 thirds of w. There it is, 2 thirds